introduce myself. I'm Sean, and I am your MC today. That's it. All right, our next speaker, her name is Manisha. She's a senior at Homestead, and she's actually she's researched in a laboratory about stem cells and cancer. And so today she'll share her experiences and her interpretation about cancer research. And yeah, she wants to encourage people to be more interested in stem cell biology. So let's get it for Manisha.
Can you guys hear me without the mic? I'm fighting a bit of a sore throat, so if it helps, I will use the mic. Yeah? No? Okay. Is that better? Yeah, okay. Thank you. So, like Sean said, my name is Manisha, and let's talk about cancer. So, cancer, it's a word that all of us have heard, and it's a word that means something different to each and every one of us. It's a word that probably encompasses the biggest medical enigma of our time right now in the 21st century. And it's a word that, when we think about it, we think about a series of words with negative connotations. We think about loss, we think about recurrence, and we think about metastasis. And it seems that as a society, we've given up. We've decided to associate cancer with death. We've lost our faith in the scientific field to find a cure. But as someone who really loves medical research, who really loves biology, I refuse to believe that this is the end. I think that medical research is incredibly expansive, and every day there are new innovations that come around, and we have a great chance of finding the cure. But it only happens if science and society can work hand in hand. And as I'll talk about later on, there are a lot of problems when it comes to this. So we hear about cancer a lot, but sometimes it gets difficult to understand what cancer really is. So what is cancer? Well, here is a brain cell that is cancerous, cancer brain cell, and it's dividing to form a new cancer brain cell. And essentially cancer is the uncontrolled division of abnormal cells in the body. So it's amazing to see that something that looks so incredible and so interesting is capable of destroying the human body. And the problem really starts when a cell that is meant to die in the human body based on the immune system's reaction doesn't die. And it grows, and it mutates, and it grows again, and then you have a tumor. But one of the biggest issues that's actually associated with cancer is not the primary tumor that we're looking at, it's the spread of the tumors. It's the fact that when you have one tumor, you can spread the tumors throughout the body, and then you have a series of tumors, and it's very, very difficult for surgeons to go into the body and remove every single tumor, or for chemotherapy and radiation to destroy these tumors without destroying our own cells that are healthy that we need to survive. And this seems very negative, and you're probably thinking right now that there seems to be just science is way behind cancer, but I can tell you that that's not actually the case. But then you're wondering, so why haven't we seen results? And that's where things get really complicated. And it comes to the 3 E's. That's efficacy, ethics, and effects. Efficacy is, does the proposed treatment actually work? And if so, to what extent does it work without actually hurting the human body? There's ethics, or is the treatment moral? Does it follow the code of conduct that we've created in our society? And then there's effects. In the long term, what's going to be the outcome of this treatment on the world, on the people around us? And this is a hypothesis that I thought about while I was working in the lab to kind of get a grasp on this idea of, look at all these crazy things that are happening around me in all these labs. Why aren't any of them actually in practice right now? Because scientists have to overcome these 3 things every day in order to propose a treatment that can actually be used to cure cancer. And that's not to say that these 3 E's are not important. They are incredibly important because without them, science doesn't have a place in society. This is the social contract that scientists hold with society. This is how we ensure to society that the things that we do in the lab and the things that we do in the hospital work for our benefit as the human race. This is how we ensure that when we are patients, the treatments that we undergo are actually for our best interest. So the 3 E's are incredibly important. So is there a treatment or a proposed treatment for cancer that does surpass the 3 E's potentially? I say yes, and I say stem cells. And stem cells are so incredibly versatile in their uses. You can use them to work on diseases of every type and range. And it's really incredible that right now in the field, especially here in the Bay Area, so many incredible things are being done in the field of stem cells. So what is a stem cell? Essentially, a stem cell is a cell that doesn't know its own identity yet. It's a cell that we can influence to become a different kind of cell. So if we use a stem cell, we can grow neurons, we can grow blood cells. And it's incredible because think about it, if you have a patient who has Parkinson's disease, they experience the loss of brain cells, their brain cells die. And if we use stem cells, we can regrow these neurons or these brain cells to replace the ones that have died. And then we can alleviate their symptoms. And another part of cancer stem cell research that's very interesting, very cool, that a lot of people actually haven't heard about is the cancer stem cell theory, which basically states that cancer grows like stem cells. So we said before that stem cells are cells that don't know their identity yet. And the cancer stem cells theory says that a tumor starts out as a collection of cells that aren't necessarily cancer cells yet, but as they divide, they become cancer cells. And if we find these original cancer stem cells and kill them, then the tumor should stop growing, and we should be able to remove the tumor. So this seems really cool, right? It seems like, okay, this is straightforward, so why haven't we seen any research with this that actually is being put to use? And it comes back to the 3 E's. Because in this case, think about it, with the efficacy and the ethics and the effects, there are a lot of things to consider before we can actually implement these treatments. So let's discuss this with a specific research example. My own. That's me if you can't tell. Last summer I had the great privilege of working at the Stanford Institutes of Medicine, and I was working in the regenerative medicine department. So I was working with stem cells, and I was working in a pediatric neurosurgery lab. And I was studying this brain tumor called medulloblastoma. And it's a pediatric brain tumor that forms basically in the back of the head, right by where your neck meets your head. And one of the really devastating things about this tumor is that it's so close to your spinal cord, where there's all this collection of really delicate nerves that you can't, as a surgeon, going in and removing this tumor is extremely difficult. And especially because you have the problem of metastasis. Tumor cells will spread and form new tumors throughout the brain and throughout the spinal cord. And of course, these are very sensitive areas of the body, and using surgery to remove these parts of the tumors is extremely difficult. So what I was trying to do was looking at this protein called anti-CD44, and we use this protein and we stick it onto the outside of a cancer cell, and we basically signal the immune system and say, come on, immune system, kill this cancer cell. And what I wanted to do was use this protein and specifically stick it onto the metastatic tumor cells. So basically the tumors that had spread from the original tumor, I wanted to stick this protein onto those cells and then see if we could potentially get rid of those tumor cells. And so how we did this was, in my lab, they were using this method of growing the tumors in mice, and then we were able to test with the proteins and the mice. And after we took out the tumors from the mice, the tumors that we had grown, we used these proteins, and we actually found that, you can see that, this is a lot of data, but basically we found that the protein did work, and we were able to target specifically the metastatic tumors. And that's incredible. That was actually, like, as someone coming into research for the first time, I really couldn't have hoped for better results with that project. So what's the issue? Again, this seems pretty thorough, right? And it seems like, well, why don't we go along with this? Why don't we keep pursuing this? And this is where we come back, again, to the 3 E's. You're gonna see this picture a lot. So for efficacy, this treatment, before it can actually be used, for humans has to undergo countless rounds of animal and human testing. And of course, we need that because we don't want to put treatments into patients not knowing what the effects are going to be. And when it comes to ethics, because of this animal testing and the human testing, this raises a lot of questions. Is developing the treatment really worth it because of all the damage that we're doing to animals and humans in the process? Potential damage, really. And finally, effects. A lot of people think that supporting cancer stem cell research of any shape or form is really a negative thing because they're afraid of kind of the situation that will arise if we support stem cells. And that kind of comes from the idea that all stem cell research is related to embryonic stem cell research. And this is a very common misconception that people think about. Embryonic stem cells are a very heavily debated issue, and it's very understandable because it is an issue that brings up our personal moral codes, it brings up religion, it brings up the rights and wrongs that we were raised with, and everyone is entitled to their opinion about the subject. But the problem arises when people assume that all stem cell research is embryonic stem cell research, and that's simply not true. As you've seen with the project that I was helping with, that was actually not related to embryonic stem cells. So embryonic stem cells, many of you probably heard about them in the news recently. There's been a lot of news coverage about this topic. And essentially what scientists do is that when they're growing embryos in the lab, they will extract some of the very early cells of the embryos, and these cells don't know their identity yet, so they're basically like stem cells, and you can use them to grow different types of tissue cells, like are listed here. And the problem here is that people think, okay, embryonic stem cells, this is a very touchy topic, but it's important to remember that this is only a subsection of cancer stem cell research. Scientists right now are looking at incredible things like how can we reprogram our own body cells to be stem cells so that we can surpass using embryonic stem cells at all. But without the idea and the general knowledge of the support of cancer stem cell research, it's impossible to overcome this problem. So it's important to know the distinction that not all stem cell research, not all cancer research is related to embryonic stem cells. But this is very science scary. And a lot of you are probably thinking, how does this apply to me? Why should I even care? And that's a really good question, because as someone who, if you're not in the science field, if you're not interested in the science field, it's important to know that even so, you are affected by these things that happen in the laboratory every day. Because as J. Michael Bishop said, science now finds itself in paradoxical strife with society. Science is so undeniably intertwined with society nowadays. Things like mass media, public opinion, even the internet influence